The transport layer is a layer in the TCP/IP networking model that provides communication services between two network endpoints. It manages the means of transportation of data. In other words, it decides how data is transported. Should we prioritize speed or reliability? The transport layer has two main protocols, TCP and UDP. TCP is a connection-oriented protocol. It uses a three-way handshake to establish a connection. TCP provides reliable, ordered, and error-checked delivery of data between applications. It ensures that the data is transmitted correctly and in the correct order. TCP also performs flow control, which regulates the flow of data between the sender and the receiver. TCP is used in HTTP for web browsing, SMTP for delivering emails, FTP, SSH, databases like MySQL, and any other protocols requiring reliable data transport. All these require a reliable data transfer. Take for example SMTP protocol, which is used for sending mails. For example, if JP were to send an email to Joanne, JP wants a 100% guarantee that his email reaches her. If, for any reason, parts of the email would be dropped, JP would become mad furious. Typically, all people would expect mail delivery to be reliable. There will be other videos explaining TCP more in details. Now let's move to UDP, which stands for User Datagram Protocol. Unlike TCP, UDP is a connectionless protocol that is designed to be fast and simple. We mentioned previously that TCP requires a three-way TCP handshake to establish a connection before sending any data. Only after this connection establishment can the two ends communicate over TCP. Well, in UDP there is no handshake and no connection establishment. Two hosts can directly send to each other UDP packets right away. UDP also does not provide the reliability and error checking features that TCP offers. TCP guarantees that data is transmitted correctly and in the right order, but this comes at the cost of increased overhead and latency. UDP, on the other hand, does not guarantee delivery or order, but it is faster and requires less network resources. For example, UDP is used as in voice over IP applications, where real-time voice communication is critical. To avoid interruptions, we discard any lost packet instead of making the receiver wait for it. Think about how the experience would be with TCP. You're listening to the other person and a packet worth of 50 milliseconds drops in transit. You would have to wait 160 milliseconds for the packet to be retransmitted and reordered, which would be annoying. In that case, it would be best to drop this 50 milliseconds of audio and continue the flow of the conversation.
Hi, how are you?
Instead of,
Hi. How are you?
In these applications, it's more important to have the conversation be fast and uninterrupted, rather than ensuring that every single packet of data arrives correctly. With UDP, the data is transmitted quickly, and any missing packets can be simply discarded, without impacting the overall quality of the communication. The header size of UDP is smaller than that of TCP, which also contributes to its speed and simplicity. The UDP header is 8 bytes long, while the TCP header is 20 bytes long. This means that UDP can transmit more data with less overhead. The transport layer also assigns port numbers. Technically, they are not like this, in the beginning and in the end, but we will represent them this way for better understanding. The port numbers are located inside the transport layer header, whether it is a TCP header or a UDP header. The port number identifies the application that is sending or receiving the data. Ports before 1024 are reserved, for example port 80 for HTTP, 443 for HTTPS, 53 for DNS and 22 for SSH. That's why clients issuing requests would get assigned random ports between 1024 and 65535, like Joanne's browser in this example. When data is transmitted from one host to another, it is encapsulated into a packet that contains the source and destination port numbers, among other information. In summary, the transport layer is responsible for managing the transmission of data between applications running on different hosts by providing reliable, ordered, and error-checked delivery of data through TCP and best effort delivery through UDP. That was our quick explanation of the transport layer. For more deep dive, continue to the next videos.